No GPU, no engine, no graphics library. Every pixel of this was written by the processor 1 byte at a time. Last time the screen turned out to be memory, this time the program turns out to be a file, and the file turns out to be the program. Assembly is not a different kind of programming. It is the same bytes as before, written one step closer to them. Every line you are about to see becomes 2 or 3 bytes, and we are going to look at every single one of them. There is no compiler today and no linker either. One program reads the text and writes the finished file, and that program comes with the source, so nothing here has to be bought or installed. So, Volkov Commander as an editor and nothing else. A new file, and this one is called hello.asm. And the first line is the one that decides everything. Format binary as com, not a switch on a command line somewhere. The program itself says what kind of file it wants to be. Now the strangest line in the file. The first 256 bytes of the segment belong to DOS. It keeps its own notes there about the program that is running. So our first instruction sits at 100 hex, not at 0. The program itself put the address of the text into DX. 9 in AH is the DOS function number for print a string. And interrupt 21 hex is DOS itself. Last lesson we rang interrupt 16 for the keyboard and interrupt 10 for the video BIOS. Same doorbell, different door. Function 4C is this program is finished. Without it the machine carries straight on executing whatever bytes happen to come next, and those are not ours. And the text, the $sign is not decoration. Function 9 has no length to work from, so it prints until it meets 1. That is the whole program, 10 lines, and one of them is blank. F2 saves it, escape leaves the editor, and Ctrl-O hides the panels so we can see the DOS prompt underneath. One command, the source in, the file out, and there is no step in between, no object file, no linker, nothing to configure. 18 bytes, it tells us the size itself, and that number is about to be the whole lesson. And it runs. Now the part this lesson is for. Let us look at the file we just made. 18 bytes, not 18 kilobytes. The entire program, on one line, and the letters of the word are sitting there in plain sight on the right. That little viewer is not a tool I downloaded, by the way. It is 150 lines of assembly in the same repository, built by the same assembler, and by the end of the series you will be able to write it. Today just has to show us bytes. So let us name them. Everyone. BA, 0C, 01. That is MOV-DX, and then the address 010C, low byte first, because this processor writes numbers back to front and always has. B4, 09, MOV-AH, 9, 2 bytes. CB, 21, interrupt 21 hex, and look further along the line CD 21 again, further on. The same instruction is the same 2 bytes wherever it appears. That is all an instruction is, a number the processor recognizes. B8, 00, 4C, MOV-AX, 4C00, same shape as the first one. And then the last 6 bytes are not instructions at all. 48, 45, 4C, 4C, 4F, 24, H, E, L, L, O, and a $sign. The letters you typed, sitting in the program, in the order you typed them. Nothing in the file says which bytes are code and which are text. Nobody labeled anything. The only thing that decides is where the processor starts reading and where it goes next. Which means we can change the program by changing the file, not the source, a file. The text starts 12 bytes and you can count to it on the screen. 5 letters at offset 12. The assembler has not run. Nothing has been recompiled. The source file on the disk still says hello. And there it is. We edited a program by editing a file, because there was never any difference between the two. A COM file has no header, none at all. DOS finds a free segment, copies the file into it starting at 100 hex, and jumps to the first byte. That is the entire loader, and there is nothing else to it. Which is why the file offset and the address differ by exactly 256, and why we wrote org 100 hex at the top without really saying why. Now you can see the reason. It is where the file lands. An EXE is the other answer to the same question. Same program, written the ordinary way, and it is worth seeing what that costs. Format MZ, 2 letters, and they are somebody's initials. We will meet them again in a minute. And straight away, 2 declarations a COM has no way of making, where the program starts, because unlike a COM, it does not simply begin at the top and a stack segment of its own. A COM starts at 100 hex because there is nowhere else to start, and its stack is whatever is left at the top of its single segment. These go first, and not because it reads better. The entry point names a segment we have not written yet, and the assembler wants to hear about it before that segment turns up. Put these 2 lines at the bottom instead, and it refuses to build at all. Now the data, in a segment of its own. It is called vars and not data, because data is a word the assembler keeps for itself. Segment names are yours to choose, just not that one. And the code goes in a segment of its own too. Here are the 2 instructions a COM file never needs. The text is somewhere else now, and only the loader knows where it put it, so before anything can be read, DS has to be pointed at it. And that is the whole of it. 15 lines against 10, and every one of the extra 5 is the program explaining itself to a loader that has to put it somewhere. Same assembler, same shape of command. The only thing that changed is a line inside the file. Same output, near enough. Now look at what it cost. 81 bytes against 18, and we can see exactly where they went, because the first thing on the screen is the header. 4D, 5A, Emma D. Mark C. Bykowski, who wrote this loader, signing his format in the first 2 bytes of every DOS executable there has ever been. Nearly 50 years later, your machine still checks for those 2 letters. Then a number that says the header is 2 paragraphs 32 bytes, so the program itself does not start until offset 20 hex, and another that says there is 1 relocation to fix up, with a list of them beginning at 1C. And that single relocation is the whole point of the header. Look down at the code. B80000 MAVX 0. But 0 is not the answer, it is a blank, left for the loader to fill in, and the relocation entry is what tells DOS which blank to fill. DOS adds the segment it actually loaded us at, and only then does the next instruction point DS at the text. That is the whole distinction, and everything else follows from it. An EXE can be bigger than 1 segment, so it needs a list of every place that has to be corrected once the loader knows where things landed. A COM file cannot need such a list, because everything in it is inside 1 segment, which is exactly why it can simply be copied into memory and jumped into. So, a file on a disk, a copy of it in memory, and a processor that starts reading at 1 address and does not stop. Everything else in computing is stacked on top of that, and that part has not changed since. And if you want to do this yourself rather than watch it, there is a DOS prompt in the description, in a browser tab, with this assembler already on the disk. Type make and you have built everything I just built. Nothing to install. Next time, graphics by hand. A dot, then every color this machine has, and that picture comes out slanted, which turns out to prove something about how a screen is actually put together.